Welcome to IQ Online Classes. So today we are going to do angular motion. This is engineering science from physics. So here the first thing, what is angular motion? What is angular motion? That's the first question here. What is angular motion? So this angular motion is just motion about an axis. So motion about an axis. So this is what we call angular motion, just motion about an axis. So what do we mean by this? For example, of this circle here. Okay? We have the center here, and we know that the distance from the center to here is what we call the radius. Okay? And again, we have something like this of this radius here. Okay? Then what do we have here? So here we have the angle. So here we have the angle. And what is this? This is what we call the arc here. This is the arc here. So this is the circle. That's why this one is angular motion, just motion about an axis here. So just moving around the circle in a circular path, which is about an axis there. Okay? So from here, let's make other things. Let's say 2. What is radian? What is radian there? So radian, we're just talking about an angle subtended by an arc, and whose length is equal to the radius of the circle. Radius of the circle here. Okay? So radian, just an angle that is subtended by an arc and whose length is equal to the radius of the circle here. Okay? Number 3 here. What is angular velocity? And number 2 here, the question is what is angular velocity? So what is this angular velocity here? So we know that velocity is just the rate change of what? Displacement. But in this case, because we are talking about angular, so velocity is the rate change of what? Angular displacement. So this is the rate change of angular displacement here. Okay. So because we are talking about angular motion in the front of displacement, we just have to add the weight angular. So angular velocity is just the rate change of angular what? Displacement. Okay? Here, number 4 here, let's say what is angular displacement? What is angular displacement? What is angular displacement? Number 2 here, the question is what is angular displacement? So we know that displacement is just the rate change of what? So displacement, so know that displacement is just the distance covered in a specified direction. Right? That's a normal definition for displacement. But in this case, because we're talking about angular displacement, so angular displacement here, just the distance here. So we have this here. Okay, so angular displacement, we are just talking about this angle here that is turned through here. This angle here turned through. So angular displacement is the angle turned through. This is angle turned through. So this is how you define angular displacement. Angular displacement is just the angle that is turned through there. Okay, so what is the next question? So what is number 5? What is angular acceleration? What is angular acceleration? This angular acceleration. What is angular acceleration? Okay. So what is angular acceleration? Because we know that the linear acceleration is just the rate change of velocity. But here, because we're talking about angular motion, so this angular acceleration is just the rate change of angular velocity. So this is the rate change of angular velocity. Okay. So angular acceleration is just the rate change of angular velocity here. So these are the definitions that we need to know on angular motion. We need to know these definitions on angular motion. So the first one, what is angular motion? You need to know this. What is radian? You need to know this. What is angular velocity? What is angular displacement? What is angular acceleration? We need to know all those things there. Okay. But here, because we are talking about angular motion here, because here we are talking about angular motion. So, like for example, for velocity is represented by letter v, but in this case, because we are talking about angular velocity, it will be represented by something like this. Listen, it is represented by something like this here, more like a W, but here is omega. It's just a Greek letter omega, which is W here. So what about angular displacement? So because we say angular displacement is just the angle turned through, meaning it will be represented by what? By theta then. Which is like this. Okay. What about angular acceleration? Well, we know that linear acceleration is represented by A, but here it is represented by what? Something like what? Alpha. It's represented by something like alpha here. Okay? So meaning all the letters will change here. The letters will change here. Okay? So here, what's the next step here? So we need now to compare angular motion and linear motion. So we need to compare angular motion and linear motion. So let's compare angular motion and linear motion. So let's say this is linear here. And here's what? Angular motion. Okay. So linear and angular motion here. So we need to compare them. So what is the first equation on linear motion? So we know that the first equation is v is equals to u plus what? Plus at here. This is the first equation in linear motion, but on angular motion, this v would change into omega, which is w. So it will be something like this: w final, b equal to the initial, which is what? W initial plus acceleration will change to what? To alpha multiplied by t. So meaning this is the first equation on what? On angular motion. So the second one is this one says v squared equals to what? U squared plus what? 2a what? 2as. Okay? But here, this v now will change to what? W final squared is equals to what? W omega squared initial plus what? 2, and the acceleration is now alpha. What is this s? This s is displacement, and now displacement is what? Is alpha. So meaning this is our second equation. Okay? Number 3 here, we have this equation where say s is equals to what? V plus u over 2 multiplied by what? By t here. Okay? So here, this s will change into what? Into theta. Being equals to this v now is what? Omega final plus what? Omega initial over what? Over 2 multiplied by what? By time there. So meaning this is what? Our third equation here. Okay? Number 4, we have this equation here saying s is equals to what? Ut plus half at squared. Ut plus half at squared. So meaning this s will turn into what? Alpha. And this u is what? W initial, which is omega initial multiplied by t plus half. And this acceleration now will change into what? Into alpha. You have t squared here. So meaning this is our what? This is our fourth equation here. Okay? What is the other equation? Let's say 5. So we know that speed equals to what? Distance over what? Over time. So we know that speed, which is v. So v equals to what? D over what? Time I. So but in this case we know that this distance is what we call displacement here. So meaning it will be what? W is equals to what? Alpha over what? Over time. Or angle turned through over what? Time. Angle turned through over time here. Okay? Okay, let's add other equations here. Okay? So these are the equations for angular motion here. These are the equations for angular motions here. So this is number 1, number 2, 3, 4, 5 here. So let's add, let's say number 6 here. We have the equation for number of revolutions. So how do you calculate the number of revolutions? Say n, which represents the number of revolutions, is equals to what? Angle turned through, or the displacement there, angular displacement over what? Over 2 pi. Over 2 pi. So this n represents the what? The number of what? Revolutions there. So number 7 here. Number 7 here, which equation do we add here? Okay, let me add it from there. So here on number 7 here, they'll add weights like this, they say. They'll use this weight maybe peripheral. Okay? Circumferential. You can also say tangential. Or they can say linear. Okay? They can use any of the weights. So number 7, for example, they try to find the linear velocity or find the linear speed. So meaning you have to find the linear speed or the normal speed, but it should be connected to what? To angular motion. So how do you find the linear, peripheral, circumferential, tangential speed? So say V, which is the what? The linear, tangential, circumferential speed. They can use any of the ways there is equal to what? The angular speed multiplied by the what? By the radius there. Okay? So this is linear. You can use any word, linear, circumferential, and this is the what? The radius here. And this one is the what? Angular speed here, or angular velocity here. So this is the equation that we use to calculate or to find the linear speed, circumferential, tangential. And here, because we are talking about this normal V, meaning here the answer will be what? In meters per second. Okay? So number 8 here, let's put another one. What if they try to find the peripheral, circumferential, tangential, or linear acceleration? So meaning to be the normal acceleration is A, but it should be connected to angular motion should be A is equals to what? Alpha, which is the angular acceleration multiplied by the what? By the radius. So meaning this one is the what? The linear, circumferential, tangential what? Acceleration. They can use any way there. Number 9. What about when they try to find the linear, circumferential, or tangential what? Displacement. So it will be the normal S, which is the displacement, is equals to what? The angle turned through, which is the angular displacement, multiplied by the what? By the radius there. So meaning here the answer will be what? Meters per second squared, and here the answer will be what? Will be what? In meters here. Okay? So these are the equations that will be used to find the linear acceleration, linear displacement, and linear speed in connection to what? To angular motion. So these equations are very important here. Okay? These equations are very important here. But here, on angular motion here, what are the units for velocity on angular motion? What are the units for angular velocity? So the units for angular velocity is now large per what? Large per second. Large per second, even here what? Large per second. So what about for angle turned through, which is angular displacement? So this one will be what? In large. Okay? Also this one is what? Large. Okay? Also large. Number of revolutions, just say maybe it's 20 revolutions, just put 20 revolutions there. Okay? And what about angular acceleration? What is angular acceleration? So for angular acceleration here, the units for angular acceleration will be what? Large per second what? Squares. Large per second squared. So these are the units here. And this angular motion here is strictly about formulas. We only use formulas and the answers will find themselves. Okay. So now we are done with all the formulas that we need on angular motion there. So now let's talk about conversions. Let's talk about conversions on angular motion. Let's talk about conversions, okay? So we need to know how to convert it from radians to degrees or vice versa. Okay, converting from radians to degrees or the other way around there. Okay, so here the conversion factor that we use is this. We say 2 pi radians, say 2 pi radians is equals to what? To 360 degrees here. So this is the conversion factor we use, okay? So 2 pi radians equals to what? 360 degrees. What if we decide to divide this by 2, both sides 2, given here by 2? So meaning these 2 and these 2 cancel. Let's say pi radians is equals to what? 360 divided by 2, this will give you what? 180 degrees here. So we can use this conversion factor because this one is simplified here. This one is simplified here, okay? So pi radian is equal to what? 180 degrees there. So let's answer this question here. Convert pi over 6 to what? To degrees. Convert pi over 60 to what? To degrees there. So convert pi over 60 to what? To degrees there. Okay? So you can get your conversion factor here, which is what? Let's say pi radian is equals to what? To 180. Okay? So pi over 60 is now in radians there. So we'll put it here, say over pi over what? Over 6 is equals to what? We want to find the answer in degrees, equals to what? X. Over what? X. So now here, we need to find this x here. So we can do what? Cross multiply here. You can cross multiply, so it will be pi x. What? Pi x is equals to what? 180 multiplied by pi over 6. So it will be 180 multiplied by pi, which is 180 pi to what? 180 pi over what? Over 6 here. But here our main goal want to remain with what? Want to remain with what? X. Want to remain with x here. So we can divide both sides with what? Pi, even here over what? Over pi here. Okay? So what do we do if we want to multiply these two here? What do we do if we want to multiply here? Here we know automatically there's a 1 down here. So this x and this x will cancel to be x is equals to what? If we want to multiply, you twist what was down here will go up and what was up will go down. So it will be 1/8 pi over 6 multiplied by this one will go up 1 over what? Pi. So this pi and this pi will cancel. Then from here to what? 180 divided by 6. So meaning x is equals to what? 30 degrees. So we have converted from what? From radians to what? To degrees. We have converted from radians to degrees. So we use this conversion factor even when we are converting from degrees to what? To radian. To be the same thing, use the what? The same conversion factor here. Okay? But it's not that important here, but you should know this one. Okay? So again, let's talk about converting from revolutions per minute to what? To large per second. Let's talk about converting from what? Revolutions per minute to what? To large per second. Okay? How do you convert from revolutions per minute to what? To large per second? So, converting from revolutions per minute to what? To large per second. Converting from revolutions per minute to what? To rad per second here. Okay? Converting from revolutions per minute to rad per second. So here we have the formula. The formula is what? 2 pi n over what? Over 60 here. What is the meaning of this n? So this n represents the what? The speed in revolutions per minute. So this n represents the what? The speed in revolutions per minute. The moment you put that given value or the speed revolutions per minute here, you multiply it by 2 pi over 60. The answer will be what? In rad per second there. The answer will be rad per second. So let's answer the question here. Or this is number 1 here. Or you can use this one. Let's say you can say the given value multiplied by 0.10472. Okay, so what is the given value? So the given value is the what? Speed in what? In revolutions per what? Per minute. So the moment you put the given value here, you multiply it by this number, it will be what? The answer will be what? In rads per second. So the answer will be rads per second. So let's answer a question here. Let's answer a question here. Say question. So question here, convert 2000 revolutions per minute to what? To rad per second. Or to rad per second, to rads per second. So convert 2000 revolutions per minute to what? To rads per second here. So using our first formula here, we say 2 pi n, and what is this n here? So this n here is the given value, which is what? The speed in revolutions per minute, which is what? 2000 here. Divide by what? 60. So what is the answer here? What is the answer? 2 pi multiplied by 2000 divided by 60?
209.4.
209 what?
4.
209.4 rads per second.
Yes, sir.
Or rad per second. So 209 rads per what? Per second. Or you can use this one here. Let's say. Or let's say, what's the given value? 2000 multiplied by 0.10472. What's the answer? To give you the exact same answer, which is what? 209.4 rads per second. So we can use any of the two here to convert from revolutions per minute to what? To rads per second. Rads per second. So when you have answered the questions on angular motion, make sure it's a must you have to convert the what? The speed from revolutions per minute to what? To rads per second before you start doing anything. So you need to convert the speed from what? Rads per second to what? To revolutions per minute before you do any calculation there. It's very important. So you need to master all the 9 formulas there. You need to master all the 9 formulas, and this topic you just use formulas direct there. Okay. So let's answer this question. This is an exam question here. So a shaft has an angular speed of, or angular velocity. Say velocity here. So a shaft has an angular speed or velocity of 2000 revolutions per minute. Okay. Find the time it will take to make 350 complete revolutions here. So a shaft has that angular velocity of 2000 revolutions per minute. Find the time it will take to complete the 350 revolutions, okay? To make 350 complete revolutions here. So here's solution. Okay? So here the first thing we need to do is to put data here. What do we have? What do we have here? So the first thing we have there, we're given the what? We're given the angular speed. So we're given the angular velocity, which is what? Angular velocity, which is what? 2000 revolutions per minute. Okay. Number 2, what else are we given there? So we're given what? Number of revolutions, which is big N. Number of revolutions, let's say 350 revolutions there. Revolutions. And what are we told to find there? We are told to find the what? The time. We are told to find the time here. We are told to find the time here. Okay? So here, which equation we use here? And why are we given this number of revolutions here? Why are we given this number of revolutions here when we know that there's no equation that will connect time to number of revolutions? So why are we given this number of revolutions here? So we're given this number of revolutions here because they know that there's a relationship between the revolutions and the what? And displacement, or the angle turned through. So using this number of revolutions here, we can find the what? The displacement. So the first thing we need to do here is to find the what? The displacement here. So how to find the displacement? So you say number of revolutions here is equal to what? The angle turned through, which is the displacement over what? Over 2 pi here. Over 2 pi here. So what is our main goal here? Our main goal is to find this theta here, which is the angle turned through, or the displacement. So what is the number of revolutions here? So the number of revolutions here is what? 350. B equals to what? What is this theta? We don't know. Over what? 2 pi here. So we want to find this theta here, or the angle turned through to be. Angle turned through equals to what? 350 multiplied by what? 2 pi. So what is 350 multiplied by 2 pi? What is 350 multiplied by 2 pi?
It's 2199.11.
91 point what? Point 1.
Yes.
Point 1 what? Lads here. So we have found the what? The what? The displacement, or the what? The angle turned through. So mean you have what? 199 point what? Point 1 what? Lads here. So now from here we need to look for an equation that will connect the angular velocity, time, and the what? And the angular displacement here. We know that angular speed is equals to what? The angle turned through over what? Over time. So meaning this equation that will connect this angle turned through, the angular displacement, the angular velocity, and the what? And the time there. But this angular speed here is given in revolutions per minute, and on angular motion it's a must. You have to convert from revolutions per minute to what? To laps per second. So we need to convert this one into what? Laps per second there. So how do we convert that one into laps per second? So use the formula, say 2 pi n over what?
60.
2 pi n over 60 here. Okay? So what is the number there? So say 2 pi multiplied by what is n there? N is what? 2000 over what? Over 60. So what is the answer here? What is the answer here?
2009.4.
2009 point what?
4.
0.4 what? Laps per second. Laps per second here. So meaning you have converted this one from revolutions per minute to what? To laps per second. So now what's the next step here? The next step here is just to introduce the formula and replace the value. So say, so the formula is what? Angular speed is equals to what? The angle turned through angular displacement over what? Over time. And our main goal here, we want to find what? Time. So what is the angular speed here? The angular speed in laps per second is what? 209.4 being equal to, what is this angle here, which is theta? What is the displacement? 2199.1 over what? Over t here. So our main goal is to find t. So from here you can do what? Cross multiply. So it will be 209.4 t being equal to what? 1 times this one to what? It will be 199.1. We want to remain with t here. What do we do? We divide both sides with what? With t. With what? 209.0. It's 209.4 over 209.4. So meaning this and this will cancel here. Then t is equals to what? What is 2199.1 divided by 209.4.
10.5.
So 10.5 what? 0.5 seconds. So this was the time here. So this was the time here. So here, direct, just use the formulas here. Okay? So let's answer the second question here. Let's answer question 2 here. So a grinding wheel of diameter 20 centimeters and rotating at 47.75 revolutions per minute accelerates uniformly at 0.5 laps per second squared for 30 seconds. Find, the first question, find the final angular speed. Number 2, find the peripheral circumferential speed. Number C, find the angle taken through by the wheel during this time here. So find the angle taken through by the wheel during this time here. Okay? So let's answer this. Let's start with the first one here. Let's start with the first one here. So what should be the thinking process on the first one here? So we need to look for an equation where we have the final angular speed, we have the initial angular speed, we also have the acceleration, we also have the what? The time. That should be the thinking process. We need to look for an equation that will connect the initial speed, the moment you see the word at. So meaning this is the what? The initial angular speed. So we need to find the equation that will connect this one, the initial angular speed, the time, the angular acceleration, and the what? And the final speed. Okay? So which equation do we use on angular motion? So automatically you know that is this equation say omega F or WF is equal to what? W initial plus what? Alpha T. So from here you see that this one, we are told to find this one. This one is part of the question. This one is also part of the question, and this one is also what? Part of the question there. So meaning this is how the thinking process should be. You look for an equation that will connect the given values and what is not what? Given. Okay? So meaning here, how do you answer this one? Say W final is equal to what? What is the initial angular speed here? So the initial angular speed is this one here. And this initial angular speed is given what? Revolutions per minute. So the first thing you need to do is to convert it to what? Laps per second. How do you convert it to laps per second? So converting this one to laps per second, you bring your formula, say 2 pi n over what? 60 here. Okay? Then from here we say is equal to what? 2 pi multiplied by, what is this n? This n represents the speed in revolutions per minute, which is what? 47.75 over what? Over 60. So what is the answer?
5.0.
So the answer is what? 5 laps per what? Per second. Okay? So meaning this 5 is what we put here, which is the initial speed, let's say. 5 plus, what is the acceleration there? The acceleration there is what? 0.5. And what is the time? The time is what? 30 seconds. So multiply by what? By 30. Multiply by 30 there. So what is the answer here? So say, you know that 0.5 multiplied by 30 is just the same as what? 30 divided by 2. 0.5 multiplied by 30, this one will give you what? 15. So meaning it will be 5 plus what? 15 giving you what? 20 laps per what? Per second. So meaning this was the first answer for the first question. So meaning this is what? A. So this was A here. What about B? Let's answer B there. So B. What are they asking us in B there? So B they are saying find the peripheral or circumferential speed. So meaning here they want us to find the what? The linear speed. And which formula do you use to find the linear speed? I gave you the formula earlier in the video. The formula that we use to find the linear speed, we say V is equals to what? V is equals to what? Angular what? Angular speed multiplied by the what? By the radius here. What is the angular speed? The angular speed is this final angular speed that you have found here. Okay? So it will be V is equals to what? 20 multiplied by, what is the radius here? So you can see that in the question here we are given the what? The diameter. And we know that radius is equal to what? Radius equals to what? Diameter divided by what? By 2. So meaning when you divide the diameter by 2, it will give out what? The radius. But the first thing you need to do here, this one is not in centimeters. You need to take it what? To meters. So how do we convert 20 centimeters to meters? So from here you can just say 20, you divide it by what? By 100. So the answer here is what? 0.2 meters. So meaning this is still what? Diameter. So how do we find the radius from this diameter here? Say R is equal to what? 0.2 divided by what? By 2. What is the answer? R is equal to 0.1 meter. Okay? 0.1. So meaning on this radius here, you put 0.1. So what is the answer here?
2.
V is equal to what?
2.
2 what? Because we are talking about the linear circumferential tangential, meaning to what? Meters per what? Per second. So we have done the equation here. Okay? So now, the last question here. So what is the last question here? So the last question here, they are asking us to find the what? The angle turned through by the wheel during this time here. So they want us to find the angle turned through by the wheel during these 30 seconds here. So how do we find the angle? How do we find the angle turned through by the wheel? So how do we find the angle turned through by the wheel during the 30 seconds there? The angle turned through by the wheel. So the angle turned through by the wheel, so meaning we use the equation for what? For angular displacement. And here, all the equations for angular displacement will work in this way. So let's get the simple one to say angular displacement is equal to what? The angular speed final plus the initial over what? Over 2 multiplied by what? Time. Okay. So we are taught to find the angle turned through, which is this angle turned through here. When we use this formula, say W final plus W initial over 2 times what? Time. Or omega final plus omega initial over 2 multiplied by T. So in this case, let's say the angle turned through is equal to what is the W final there? The W final there was what? 20. What about the initial there when you convert it into what? 5. Over what? 2. Multiplied by what was the time there? 30 seconds. Okay? The time was 30 seconds there. So what is the answer here? What's the answer here?
12.5.
Here's 12.5. 12.5 multiplied by what? 30. So you only do the mathematics, give you 12.5. So what is the answer?
375.
375 what? Rad. Stay. So meaning we are done with this question here. So here on angular motion, it's all about the formula. So all you just need to do is to master the formulas and make sure you use the correct formula in each and every question. Thank you. See you in the next video.